All righty. So, hello, Ceph community. Nice to join you virtually in this new event, and thanks to Mike for making this all happen. Our marketing manager won't let us get away from the idea that we have to introduce ourselves. So, very briefly, I had the privilege of spending my entire career in free and open source software. I'm the product management director for Ceph as a platform in Red Hat and soon in IBM. Previously, I was the Ubuntu server PM at Canonical. If you remember 1404, that was my favorite accomplishment there. And if you go back the decade, the systems management czar that terrified everyone at SUSE. There are a few things here on the list that I worked on. I was the maintainer of Man. I suppose I technically still am, although we consider Collins version preferred these days. So I don't have that much to do. But it's still there on your Mac. If you type man, you find me. Shameless plug, I have a book by O'Reilly, and that's why you see me there surrounded by clouds in my author portrait. And well, I think that's plenty enough for me. So Anna.
Hey, I'm Anna mcTaggart. I use they, them pronouns, and I work on security at Red Hat and soon to be IBM. I'm currently in incident response at Red Hat, and I'll be working on security for all of our storage products, such as Cluster, ODF, and Ceph when we move to IBM. I did grad school at UCSC in formal methods and also storage security. I did my undergrad at UMass Amherst, and in my free time, I love to hike with my dog and garden.
And there would be a third speaker, which is Mike Hackett, who unfortunately is super busy holding the fort for our support team, so can't be with us today. But he is an equal contributor to this work. So thanks to him for all that he has put in. Now, we're not going to do the introduction to what Ceph is in this session. If you don't know what Ceph is, you can ping me later and I'll tell you, but I don't think that's necessary. And so same for Rook. They're great. You know everything already. So security practices harden a specific point of the infrastructure. Cherry-picking practices without a model of the threat and the attacker is not a viable strategy. The joke usually goes, if you want to protect from all possible threats, you should turn the computer off, bury it in concrete, drop it at the bottom of the ocean, shoot it in the sun, and things like that. In other words, absolute security is not something that's usable. It needs to be defined in the context of an actual threat model. Are you facing script kiddies or GRU or some dreaded privileged insider scenario? Some of these want to steal your data. Others want to crypto lock you and hold you for ransom. Others yet may be just satisfied with disrupting your service. So, oh, look at that. IT is reminding me, appropriate in a security presentation, I guess. Excuse me 1 second. There is a pending update that needs to be installed. All right, back here. Are the slides back up?
Yes.
Hopefully, yes. So some of them may want to actually cause damage. Others may be satisfied with disruption, not need to actually steal your data. So the model of who you're facing is essential so that you can pick from the vast collection of hardening practices you can put in place, which ones make sense for you and your users. So let's dive right in. The public security zone is an entirely untrusted area of the cloud. Here we're looking at the network first. It could be the internet as a whole, or just networks external to your cluster that you have no authority over. Data transmissions crossing this zone should make use of encryption. Note that the public zone, as I just defined it, does not include the storage cluster front end. The Ceph public underscore network, which defines the storage front end and properly belongs in what is called the storage access zone. So maybe not the most ideal terminology there, but that's what it is. The Ceph client zone refers to networks accessing Ceph clients like the object gateway, the Ceph file system, or block storage. Ceph clients are not always excluded from the public security zone. For instance, it's possible to expose the object gateways as S3 or Swift API in the public security zone. Actually, that would be a very common scenario, in fact. Next, the storage access zone is instead an internal network providing Ceph clients with access to the storage cluster itself. Finally, the cluster zone refers to the most internal network, providing storage nodes with connectivity for replication, heartbeat, backfill, and recover. This zone includes the Ceph cluster's backend network, called the cluster network in Ceph. Operators often run clear text traffic in the cluster zone, relying on the physical separation or VLAN separation from all other network traffic. And here is a good example. This would not be a valid choice if your threat model includes an adversarial privileged insider, whereas it's perfectly fine if your threat model is for script kiddies. So again, you need to choose what you're doing based on what your threat model is. These four zones are separately mapped or combined depending on the use case and the threat model in use. Now, components spanning the boundary of two security zones with different trust or authentication requirements must be carefully configured. These are natural weak points in network architecture and should always be configured to meet the requirements of the higher level security zone of the two. Obviously, misconfiguration here is a problem, but these are also natural attack targets in terms of places where people look for exploits. In most cases, however, your focus should be on the security controls due to the likelihood of attacks to try to escalate from one zone to the next. Operators should consider exceeding zone requirements at integration points, which for a storage product is often easier to accomplish than for a compute product. For example, the cluster security zone can be isolated from other zones easily because there is no reason for it to connect to other zones. Conversely, an object gateway in the client security zone will need to access the cluster security zone's monitors on port 6789 and OSDs on full range of ports, and will likely expose its S3 API to the public security zone, exemplifying the zone crossing scenario that I was just describing. What happened here? Oh, sorry. Did I turn off notifications? Maybe that's what I did wrong. Okay. Okay. So, sorry about that. We're getting interruptions on the presentation. Now, okay, and that's it for the network part. And I think this is where Ana takes over.
Yeah, so going on to sort of what we do in product security, in addition to the design of Ceph storage, let's talk a little bit about what product security at Red Hat does. Product security at Red Hat follows a secure development lifecycle with the goal of reducing risk and improving security for both Ceph and Rook. We suggest improvements, we pen test, we manifest all of our dependencies, even the really obscure ones, hidden in some container somewhere. We review vulnerabilities, we track weaknesses and exploits. We approve errata releases, checking details. We review all new releases, checking new libraries for CVEs, checking old ones too. And we've somewhat recently, within the past year, we split it into incident response and security architect roles, in part to ensure good geographic coverage and preventing any lapses covering all stages of our software. Because I don't want to work at 2 a.m, and nobody does, and nobody's their sharpest then. So one of these branches is called incident response. This is the branch that I currently work in. We respond to incidents so we can release fixes in a timely manner. We investigate all vulnerabilities that are reported to us, just in case some really minor one is in fact pretty serious. We work with upstream, we work with engineering, we want to make sure that all flaws are fixed. We also try to coordinate all publications to prevent disclosing a flaw before engineering is aware. And in some cases, we'll even wait to publish until we have a fix ready. This all depends on whether or not we're actually able to keep it under embargo. Of course, if somebody publishes something to Twitter, we can't exactly follow this process. But when we get a report to us, we really try to coordinate to minimize the amount of time that significant security vulnerabilities are public without us having a fix. We also regularly check for exploits that are discovered well after a vulnerability is published, because that can affect the severity of an exploit, of a vulnerability. And in very exciting news, we recently open sourced our incident response plan that covers our process for responding to incidents. We do this to help industry overall and really include the open source ethos within incident response. On the other side of things, prior to release, our security architect works to improve Ceph by working on the design of it. We manifest all dependencies. We have a list from engineering, and then we also automatically do this with tools, as I said earlier, to make sure that we don't even miss the most obscure container pulling something as part of a build somewhere that may not seem obvious, but could still be exploitable in a really theoretical scenario. So we're really doing a good job manifesting everything. And of course that's required, but we're actually getting everything. We also, as I said before, carefully review all major releases, our new libraries, for CVE's vulnerabilities. We review all exceptions to security policy. In some cases, we'll approve them, and in other cases, we'll say, hey, engineering, you actually have to go fix this. And we work with the compliance team to validate Ceph to our security standards and any policies that we're implementing. And in addition, we've worked to improve cryptographic algorithms used in Ceph. We implement those in ways such as the improvements to Messenger 2, and we work on other design choices like the key storage improvements and RGW. And then moving on to some of how we do encryption, let's talk about encryption and key management for Ceph. Server-side operators overwhelmingly choose to encrypt data at rest using the Linux Unified Key System, key setup, better known as LUKS, and all data and metadata of a Ceph storage cluster can be secured. I'll give it one moment. Federico, let me know if you'd rather have me put the slides up. Thank you. Yeah, so with data at rest, we're encrypting it using LUKS. All data and metadata of a Ceph storage cluster can be secured using a variety of DMCrypt configurations. Almost all of Red Hat's customers choose to. It's not a requirement, but most people are doing it, and it makes a lot of sense too. We are also enabling security best practices by locating our monitor daemons, our mons, on separate hosts from the OSDs. This basically means that the drive or host is physically separated from its decryption keys. You need both drives to get the keys and the data, and this ensures the anti-affinity of the keys and the data they encrypt, obviously. The object stored gateway, in addition, or RGW, has additional capabilities. This includes encryption at ingestion time, the use of per user keys as opposed to per drive keys. We allow key rotation with tools like Vault. We have support for AWS, SSE, KMS, and more. We even have Department of Defense ciphers certified under FIPS 140-2 as a standard that can be used when they're supplied by RHEL in appropriate version. As you can see, we just have a wide variety of options for key management on the slides. All of these are great options, and they're all supported just to make it as easy as possible for the user to use proper key rotation and management. And now that we've talked about encryption at rest, we got to talk about encryption in transit. Network communication can be secured by turning on the Ceph protocol encryption in the Messenger version 2.1 protocol introduced in Nautilus. This is the one that we worked with product security on. And, you know, we definitely have an option to have the legacy clear text protocol. It's fine. It's secure enough. The networks where the cluster is using the Ceph protocol are usually physically or logically isolated from access. But so for compatibility reasons, you want to have the clear text protocol as the default. At the same time, we now have an encrypted internal protocol. And again, all data at rest is encrypted irrespective of access protocol in nearly all cases. All of our customers are choosing to use those methods. And for data in transit, we're using FIPS 140-2 certified ciphers as an option. And again, we offer that option just with compatibility and overheads, why we wouldn't traditionally encrypt the backend protocols, but in most cases, the performance impact is actually really insignificant for a properly designed cluster. Our latency is overshadowed by the network communication as long as our CPU overhead is accounted for. And we have some best practices on the slide. For example, you can use TLS security from your object gateway to your S3 clients. You can use your, you know, we'll go into this, but TLS termination at HA proxy is a special case, and we always encourage network hygiene at individual nodes. So going on to the next, going on to a little bit more here, looking at specific protocols, our S3 service is usually secured between RGW and the S3 client with TLS on port 443. We do allow plain HTTP on port 80, just in case somebody needs it for some public data. It depends on the nature of your data being served, confidential versus public. And again, just like I mentioned, TLS termination at HA proxy is a special case where the link between HA proxy and RGW is in clear text. So you have to keep in mind security zones, just like Federico was talking about earlier. But provided it's located in the appropriate security zone, we have no concern. And again, just like I was mentioning earlier, standard network practices like firewalling individual nodes to only expose a cleared list of port supply. Let's not have all of our ports open to the public. Let's only have a cleared list. So best practices apply. We make it easy to have those and also have additional security practices on top of that. And now talking about Rook specifically, Rook can use custom resource definitions, CRDs, to encode many of the settings that we want. So for example, pause just one more moment. Also, with security, it's very important that it be accessible for the users. And if it's frustrating the users, they're less likely to implement the practices such as updating their computer if it is constantly asking them to do it in a presentation. Okay, so Rook specifics. Rook can use custom resource definitions to encode many of these settings. For example, we configure trust certificates for RGW, Grados Gateway, web server. Rook supports at-rest data encryption, as we discussed earlier, with in-flight Ceph protocol encryption in 1.9. Kubernetes user permission systems applies to persistent volumes. So permissions, quotas, all that comes from Kubernetes with nothing Rook needs to do. Rook supports key management systems as well, and our CSI driver, allowing individual volumes to be encrypted with their own key. This limits the scope per key. This all ensures that we can follow best practices easily, such as key rotation, revocation, and limiting the scope from each key. This limits the scope of unencrypted traffic, and it limits the scope of each key, which is a best security practice. Going on to the control plane. On the next slide. We'll be talking about the control plane. And as popularized by Ansible, SSH is used by Ceph admins, Ceph Ansible, and other day one tools to provide a secure command path for install and upgrade options as part of host management. We do this so that the dashboard is usually not exposed to the world, and yet it also needs to be reachable by the operator's workstation to be of use. The manager supports the whole infrastructure and needs to be reachable on the storage access zone, hence why we're using SSH. So you can see this is how we're implementing it with assorted different ports and where exactly we're using SSH keys. Again, with the management dashboard, for example, the dashboard access zone may be tailored to suit your local threat model. With SSH, you can definitely SSH in using a user, and then you can change to root access if needed, provided it's secured with SSH keys. There's all sorts of different practices that you can do here. Now going on to our next slide. We're going to talk about identity and access. So Ceph uses shared secret keys, which prevents our clusters from man-in-the-middle attacks by default for authentication. Now, this is all authentication and authorization are on by default. If the user isn't supplied, you're going to just give them the client.admin as the user and restrict accordingly. Now, you still need some good practices. For example, you may only want to grant keyring read and write permissions for the current user and root, with client admin user restricted to root only. You definitely don't want all users to be root as per best practices, because that just gives them way too much permission. So now let's talk about RGW briefly. With RGW and identity and access, we support the key and secret model of AWS S3 and the equivalent model for OpenStack Swift. And again, the administrator's key and secret should be treated with appropriate respect. You should use administrative roles very sparingly to reduce your risk profile. And again, your RGW's users' data is stored in the Ceph pools, as we can see for user authentication. They should be secured, as we previously discussed regarding data at rest. We can couple with OIDC providers such as Keycloak, backed with your organizational's identity provider for an even better sense of granular roles or identity access for attribute access. Really, we're trying to make this as accessible as possible for different options and allow our users to have as many different choices that are pretty secure. Going on to the next slide. I'll finish this up with identity and access, and then I'll hand it over to Federico after this. But with identity and access, we support LDAP and Active Directory users. We do recommend secure LDAP for identity services. We also, again, we support OpenStack Keystone to authenticate our Object Gateway users. In general, we just have a lot of options for identity and access that are pretty secure. And when the slides are back up, I'm going to hand it over to Federico to finish us up on the auditing slide. You are muted.
My bad. Auditing is fairly self-explicative. This is the log format that we use. You should aggregate your logs into a central location if you can. If you have a central log management system, that is highly recommended. You probably also want to purge your logs on a regular schedule. There is no sense leaving them around forever, just in case something is getting leaked there that we're not aware of. And then data retention. So this is actually a fairly juicy topic. There is a lot here. So Ceph data retention behaviors. Generally, users don't go and access Rados directly. So we look at the higher layers here. In RBD, RGW, and to some degree, the file system, we have what you could consider intentional data retention. You can go and delete objects, but for example, RBD has this new bit of functionality called the trash bin, where it essentially gives you an undo button where you can restore a volume that you have deleted if that space was not needed, or if a policy to purge it after a certain amount of time did not kick in yet. On RGW, buckets are, of course, versioned. It's part of the design of an object store, so that's a natural property. Obviously, if you want to manage data retention policies, you need to be aware of these behaviors. And then there are places where you intentionally increase the data retention, like setting up RGW for write once semantics, as a financial customer may do, or setting up multi-factor authentication on RGW to protect against, let's say, a ransomware attack, to make it more difficult to go and delete data. So these are things at the Ceph level. But once you have deleted the data, while it may not be easy to recover, an expert could still go and piece together the bits from the drive or from Rados. Maybe could not recover an entire file, but from the point of view of data sanitizing, overwriting files in Ceph is not going to do anything. Obviously, your overwrites are going to go someplace else than where the original data was stored. So for secure deletion, generally a best practice is to encrypt the drives, which you should be doing anyway, and to sanitize the drives by forgetting the key that they were encrypted with. That is much faster. It is compatible with hardware return policies. You don't have to explain to your hard disk vendor that you shredded the drives for security reasons, and you're returning them confetti for a new drive as part of the warranty process. That they may not work too well. And so it's very fast. It's compatible with RMA processes, and you should be encrypting the drives anyway. So you should have the ability to do that to begin with. In terms of hardening the binaries, these are highly vendor dependent. And these are Red Hat's choices. Of course, we run with SE Linux by default, which probably surprises no one, since in our company, SE Linux is sort of a religion. We have options to support FIPS 142 out of RHEL. So you can install RHEL with ciphers that have been certified by the Department of Defense, and Ceph will just make use of those. And then in terms of hardened binaries, you have on the left here the options that we use when we build the Ceph binaries, and on the right you have the options that are generally provided by the operating system environment and kernel, like the general mix of ASLR hardening strategies or limiting system calls that you can access, and position independent executables and the like. All of these are part of RHEL's default configuration. I believe that they're also part of Ubuntu's default configuration, so our most common OSs are covered. Of course, if you use another distribution, you should investigate what they do, because these are essentially free additional robustness for your binaries, and they make it a lot harder to exploit to exploit vulnerabilities that we may not be aware of stands in the way of crafting exploits, essentially. Okay, so that's the end of the formal presentation. Before we go to any questions, we have a few links for you in terms of resources that may have additional interesting bits. Aranios, not from Acquia Security, has a nice explanation of managing secrets in Kubernetes and how the Kubernetes secret mechanism works and how it offloads to actually secure locations, because the Kubernetes secret itself is just running a hash on the secret. It's not actually secure. But when you're storing it into some other things like HashiCorp Vault or some other external location, then that mechanism actually protects your secrets. So everything there is expanded by running. Hacking Kubernetes Chapter 6 by Michael Hausenblatt, our former colleague, and Andrew Martin covers storage extensively in Chapter 6. And it's a very recent book, so it's up to date or nearly up to date. Ceph Storage, our actual product, has a full volume of data security and hardening. We sort of worked you through the main takeaways of that, but it exists in written form. The Kubernetes documentation has a nice tutorial on encrypting secret data at rest, sort of expanding on what we were talking about at the OS level for the OSDs here. And the last link explains that alphabet soup that I had on the last slide of all the hardening options. If you are not a kernel or glibc junkie, you probably have no idea what those are or do. And there are very few places where they're documented. So the GCC documentation is a good place to start and goes and details what the actual options do. Okay, so with that, we are done. We actually have some thank you as an acknowledgement for all the people that contributed to prepare the presentation. And that's it.
All right, thank you. And we do have some questions here. The first one I'll go to here is DOS of Ceph services and scope.
I'm sorry, Mike, I didn't catch that, but go on, Anna.
I can say, so with denial of service attacks for Ceph services, we generally do, if we get a report of a vulnerability that could result in a DOS, we'll generally send it over to engineering just like we would any other vulnerability, trying to prevent and fix it. Of course, this is a very broad category of attack. So, for example, saying like, oh, it's certified against DOS. Well, what happens if somebody DOSs your internet provider at the ISP level and stuff? That we're not so much preventing against, but generally speaking, if it's an attack towards a vulnerability affecting Ceph, we will file it and fix it just like any other, including for denial of service attacks.
Okay. Another question we have, are the performance implications of encrypted OSDs known with regard to CPU usage and I/O latency?
Yes, there is a study that Ben England did, I think, a year and a half ago. I don't know if it's being released outside of Red Hat. I would have to look. Essentially, there is obviously an overhead to encryption in flight. and you can offset it with appropriate sizing of the CPUs. So if you're going to encrypt all your network traffic, you account for it at the design phase with a little bit of additional CPU. The fact that Ceph is network storage means that the latency is generally shadowed by network latency, and the encryption overhead is not going to affect latency much. But obviously, you need to size the cluster so that it has the firepower to do this. In the customers where we see encryption in flight in use, this is generally a regulatory requirement. So it's not something where there is a choice. Their regulator is saying, even if the network traffic is on a separate network, we don't care, we want it encrypted. And so they just do it, and they add a few more cores, but that's the extent of the effort. So it's not significant impact. At rest, encryption is essentially completely overshadowed by network latency, and it's something that at this point is default. I stopped tracking the prevalence of encryption at rest in 2015 when more customers than not were using encryption at rest. Now it must be in the 90% plus group. It's effectively an exception when there is no encryption at rest. It's exceedingly rare.
Okay, thank you. I think that's all the questions we got in chat. Anybody else have questions that they want to speak up on real fast?
Hey, Federico, thanks for the presentation. Hey, Anna, thanks for the presentation. I had a question about audit logs. Hey, I was recently troubleshooting an issue, and I was surprised. It was kind of a discovery for me. So when you run the CLI commands, like Ceph status or any other, read commands from the CLI, those all get logged in the audit log. However, I was surprised to not see if a volume gets created, like an RBD volume gets created or destroyed, that type of activity doesn't get logged in the audit log. Is that something? My knowledge is only up until Nautilus, so I apologize if that's changed. But is that something that you guys are? Is that configurable, or are there thoughts to extending the audit logs? Like someone deletes an RBD volume and then comes and complains to me that they lost data. I can't tell them what happened.
My first question would be whether there is a difference there between the log levels. There was an effort, it's been several years back, where a number of things were pushed into higher log levels because our logs were enormously chatty. They were developer-friendly logs, not operator-friendly logs. So probably the first thing that I would check is if maybe it's being logged at a higher level. But it seems wrong that at whatever level you're operating at, that is not being logged. So can you send me a quick note to remember, and I'll track this down. Thank you.
Yeah, Federico, I don't think this is logged because in general well, it's not logged in the audit log at least, right? So because the audit log is mostly limited to just kind of cluster-wide activity, and that means mostly things that concern Rados itself and not the higher-level applications such as block device or the file system. So when you remove an RBD image on the Rados level, what that means is a bunch of objects get removed. So that's not considered to be that big of a deal, as compared to someone, for example, creating a new key or reconfiguring the entire pool, so things of that nature. So yeah, there is. It's not a question of log levels. That just does not go to the cluster to the audit log.
Understood. Thank you, Ilya. Okay, so I guess we need to figure out if there is another log where this should go to, and how.
Yeah, I mean, I can see why you wouldn't want to log the creation and deletion of each Rados object in an RBD pool. I get that, but yeah, no, it's interesting. Okay, no, but thanks for answering the question.
Yeah, that's definitely something we can we could look. I mean, there is no reason. It would need to be designed to concern not just let's say RBD image creations and deletions, but kind of across Ceph, because like I said, right now the idea with the audit log is that it's fairly low level, and if we wanted to extend that to these higher level application specific, right. And I keep using the word application, but it's not the user application. These are just things on top of Rados. If we wanted to extend it to that, we would need a comprehensive design. Just logging, for example, creation and deletion events for RBD images. That should be fine from the perspective of not overloading the log and not overloading the cluster, because there is a natural limit on the number of RBD images you can create, just because at some point you're going to run out of well, at least if those images are used, if they're all empty, then you could potentially create millions and millions of them. But if those images are real, then there is naturally a limit. So there's no fundamental reason to not log that to the audit log. But that's not a not a short-term fix. This would need some design work and to have a comprehensive kind of story across the entire project.
An application, Rados application level log. And one that doesn't get swamped too easily. We're tracking every RGW object deletion. I think that could be interesting.